Welcome to History of Origins. Here you'll find well-sourced updates about the secret history of Earth's deep oceans. Stick with us so you never miss an update. In this video, I want to show you in a cinematic 4-act format the fiery beginnings of the universe over 5 billion years ago. How the planets were formed, born from volcanoes and rivers of molten lava. For millions of years, endless rains fell, eventually creating the oceans of our planet. All of this cooled the Earth, and over time, life began to emerge, first in the oceans, then on land, and finally with humans. Up to the present day, where our seas and beaches are sailed for trade, exploration, and leisure. Giant cruise ships cross the world's oceans, powered by modern technology that connects every corner of the planet.
Act I. Birth of Water, 4.5 billion years ago. Your episode, What Lies Beneath the Secret History of Earth's Deep Oceans. It's written in a cinematic documentary, content mixing science, storytelling, and a light touch of humor.
Before the oceans, before the sun, the moon, and even the Earth as we know it, according to what scholars have studied for thousands of years, one timeless measurement is almost certain. The world we live on today did not yet exist. It was a planet of molten fire, drifting through the universe alongside other newborn worlds. These planets collided with each other, creating massive fields of debris, fragments large and small, that could eventually become satellites in the cosmic expanse. From these violent, fiery collisions, scientists believe emerged first the sun, and then the moon. But one question naturally arises. How did the oceans form? Where did all the water on planet Earth come from? Before there were clouds, before there was blue, before there was even an ocean to drown in, Earth was on fire. Birth of water, 4.5 billion years ago. Before there were clouds, before there was blue, before there was even an ocean to drown in, Earth was on fire. Picture a planet that glowed red like a molten coal, spinning under a sky of black smoke. Temperatures soared above 1,000 degrees. The ground wasn't made of soil, but of lava, rivers of rock flowing across a newborn world. And then, one day, it started to rain, not just a drizzle, not even a storm. It rained for millions of years. Imagine that, oceans falling from the sky. So here's the question, where did all that water come from? Because, spoiler alert, the early Earth wasn't supposed to have any. 4-5 billion years ago, our solar system was still a cosmic construction site, a dusty, chaotic disk of debris spinning around a young, furious sun. In that violent neighborhood, planets didn't form gracefully. They collided, shattered, and rebuilt themselves in endless chaos. Earth, or rather, the molten rock that would become Earth, was just one of these growing worlds. Every impact added more mass, more heat, more energy. And among these impacts came a particularly rude visitor, a Mars-sized object scientists call Theia. When Theia slammed into proto-Earth, It blasted so much rock into orbit that the debris eventually coalesced into the moon. Pretty dramatic, right? The birth of our moon came with a side effect. It completely remelted the planet. Every trace of water, every hint of volatile element vaporized into space. So how did we end up with an ocean-covered world when it started as a dry hellscape? Well, there are two big suspects. One came from below, the other from above. Water from below, the planet breathes. Let's start from the inside out. Even a dry Earth isn't truly dry. Deep inside the mantle, minerals lock away water molecules in solid form, like little geologic sponges. As the planet cooled, volcanic eruptions began venting those trapped gases, carbon dioxide, methane, and yes, steam. For millions of years, the planet exhaled water vapor from its lungs of magma. It was a slow process, but picture this: hundreds of thousands of volcanoes erupting constantly, filling the sky with steam and ash. The atmosphere thickened into a choking blanket of greenhouse gases. And when the planet finally cooled enough for that vapor to condense, the heavens broke open. Rain fell and fell and fell for millions of years, until the molten craters became lakes, the lakes became seas, and the seas fused into the first global ocean. The Earth's surface hardened under the weight of its own sky, and what was once a world of fire turned into a world of water. Still, this version of events raises another question. Was volcanic outgassing alone enough to fill all our oceans? Or did the universe have a delivery service? Water from above, a cosmic delivery. Our second suspect comes from space, the icy messengers. Asteroids and comets, left over from the solar system's creation, carried water frozen in minerals and ice. Over hundreds of millions of years, these space rocks bombarded Earth in what scientists poetically call the late heavy bombardment. Not so poetic for the planet, though. Imagine daily asteroid strikes big enough to vaporize cities, flatten continents, and boil oceans. If YouTube existed back then, it would have been called the Planetary Demolition Channel. But through all that destruction came delivery. Each impact released water into the atmosphere and crust, more drops falling into the growing seas below. And when scientists analyzed hydrogen isotopes, the fingerprints of water, they found that Earth's oceans actually carry two signatures, some matching volcanic origin, others matching cometary ice. So it turns out we didn't just make our water, we inherited it. Half Earth-born, half interstellar, a true cosmic cocktail. When the sky fell, the endless storm. Now imagine standing on the early Earth. Not that you'd survive for long, but humor me. The sky is a dense, hot fog. Lightning splits the clouds every second. The rain is boiling as it hits the lava below, hissing into steam and acid. There's no blue sky, no continents, no calm beaches, only endless volcanic islands floating in a stormy Red Sea. It rained for millions of years. a hydrological marathon that filled the planet's basins and trenches. As the deluge continued, the ocean deepened, spreading across the crust like a living creature finding its skin. The first oceans may have reached depths of hundreds of meters, maybe even kilometers. And in that time, something extraordinary happened. Water began to reshape rock, pulling minerals from lava, carving chemistry into motion. The ocean became a reactor, a crucible for creation, and somewhere within its mineral soup, perhaps near a volcanic vent, the first whispers of life began. The first blue planet. For the first time, Earth reflected sunlight back into space. From afar, it would have appeared pale blue, the first true ocean world in our solar system. Venus and Mars might once have had oceans too, but they lost them to runaway heat and thin air. Earth alone found the balance. Water stabilized the crust, cooled the planet, and began the slow cycle of weather, the heartbeat of a living world. The first ocean didn't just fill craters, it filled time itself. It became the stage on which every future story, every cell, every creature, every civilization would play out. When you think about it, every drop of water you've ever drunk has been here since the beginning. That glass of water on your desk? It's older than the sun's current set of planets. It's been to space. It's been lava. It's been inside dinosaurs, kings, plankton, and perhaps a few fish with bad attitudes. That's the beauty of water. It doesn't vanish, it only travels. And every ocean wave today is just ancient rain trying to return home.
Act 2, the chemical ocean, 43.5 billion years ago. But this is only the beginning, because deep beneath those first waves, in vents of boiling rock and mineral smoke, chemistry began to organize itself into something alive.
A toxic metallic soup, bubbling with acid, methane, and iron. And yet, this is where life began. The ocean that could kill you was the same one that would one day make you possible. So how does something so deadly turn into something so alive? How did a planet covered in boiling metal water become the cradle of biology? Welcome to the chemical ocean. Last time we watched the Earth cool from fire to ocean, but what came next wasn't peace. It was chemistry, chaos, with a touch of genius. The year, give or take a few million, 4 billion years ago. The planet is still young, still unstable, still, frankly, terrible real estate. The air, mostly carbon dioxide, nitrogen, methane, and hydrogen sulfide. The ocean, hot, acidic, and filled with dissolved metals from constant volcanic eruptions. The color of the water wasn't blue, it was greenish black. The ocean shimmered with iron and sulfur compounds, giving it an oily metallic sheen. No oxygen, no ozone, no continents, no beaches, no fish, just endless ocean, storms and volcanoes. But within that alien mix, something extraordinary was brewing. The primordial soup, the surface of ancient oceans, hydrothermal vents releasing mineral-rich smoke, shimmering microbes and strange early life glowing faintly, bioluminescent plankton drifting. Let's set the scene. Imagine a young Earth where lightning flashes constantly across the horizon, striking into vast pools of chemicals. Every flash splits molecules apart, rearranging them into new forms: amino acids, lipids, sugars. The building blocks of life. It's like the world's first cooking show. Welcome back to Planet Kitchen, where today we're making life from scratch. But this wasn't cooking with a recipe. It was trial and error on a planetary scale. Billions of random experiments happening simultaneously for millions of years. Scientists call it the Primordial Soup, and honestly, it's the weirdest soup ever made. No carrots, just chaos, energy, and potential. The spark of life, or just really good chemistry. No carrots, just chaos, energy, and potential. Now, here's the question that has haunted science for centuries. When does chemistry become biology? When does a molecule stop being just a molecule and start wanting to survive? Some say it happened in shallow tidal pools, where wet and dry cycles concentrated molecules. Others say it began deep underwater, near hydrothermal vents, natural chimneys belching superheated water rich with minerals. The metal ocean, a planet in flux. Now remember, early oceans weren't blue, they were metallic. They contained dissolved iron, nickel, and other minerals from constant volcanic activity. Everywhere, chemical reactions were happening. The ocean was basically a gigantic battery. If you could see it, it would look electric. Lightning above, chemistry below. Volcanoes constantly injected new gases: hydrogen sulfide, ammonia, methane, all of which interacted with water and sunlight to form new compounds. Over time, these reactions began creating more complex molecules, things that could store energy or replicate themselves. And here's the twist. Life may have started using metal as a part of its body chemistry. Iron-sulfur clusters, for example, are still found in your cells today. They help manage energy inside every living thing. So, in a way, you're not just made of stardust, you're made of rust. The first cell, a bubble with ambition. At some point, we don't know when or where, the molecules in the ocean organized into something new. Maybe it started as a simple, fatty bubble floating near a vent. It trapped a few, and suddenly, that bubble could grow, split, and make more of itself. Congratulations, we've just invented the world's first cell, a bubble with ambition. It didn't think or feel or want anything, but it had one crucial trait: it could persist. Every version that worked made a copy, and every copy that didn't disappeared. Welcome to evolution, version 1.0. And all of this, every bit of it, happened in an ocean that would have killed us instantly. Boiling, acidic, churning, yet alive with possibilities. The oxygen problem and the great rusting. But not everything in the chemical ocean was good news. For hundreds of millions of years, early life forms filled the water with waste, molecular exhaust. One day, a new type of microbe learned a trick that would change everything. photosynthesis. It started releasing oxygen, a deadly poison for almost every other organism alive at the time. Oxygen reacted with the iron in the ocean, turning the seas red and rusting the entire planet. This was the first great extinction. Billions of microbes wiped out by their own byproduct. It sounds dramatic, but without it, complex life, including us, would never have evolved. Oxygen was destructive, but it was also creative. It remade the atmosphere, cleared the skies, and painted the oceans blue. The chemical ocean had finished its job. Now, biology could take the stage. Long ago, it dissolved metals, carried volcanic gases, and shaped the chemistry of early life. The waters we know now are the lasting traces of that fiery beginning. The ocean born from creation itself. Romantic, isn't it?
Act 3. The Engine of Life. 2.5 billion years ago, today. For billions of years, the deep ocean has kept Earth alive. It breathes for the planet. It moves the continents. It regulates the climate. It stores our history and maybe our future. Act 4, The Human Ocean, Now and Beyond. Series. What Lies Beneath? The Secret History of Earth's Deep Oceans. Half of the oxygen in your lungs right now was made by invisible life floating in salt water.
It's the deep ocean. For 2.5 billion years, the oceans have been the engine of life, pumping heat, moving carbon, sculpting continents, and keeping this fragile planet alive. It's still happening right now, quietly, invisibly, beneath your feet, as the hidden forces of our planet continue to shape everything we know. Deep below the surface, currents move, minerals react, and unseen energy flows through the earth like a living heartbeat. Context duck. By the time we reach 2.5 billion years ago, the oceans have changed dramatically. They're no longer metallic or acidic. They've turned blue, and floating in that blue are tiny architects, cyanobacteria, quietly rewriting the planet's chemistry. Through photosynthesis, these microbes released oxygen, transforming the atmosphere, cooling the planet, and triggering one of the most profound chain reactions in history, the rise of complex life. But while the oxygen revolution grabbed the headlines, something deeper was happening below. The oceans were setting up a system of motion, a planet-sized engine that would run for the rest of time. A circulation so vast and slow, it would become Earth's life support system. We call it the global ocean conveyor. The ocean starts to move. In its early days, the ocean was calm and layered, almost motionless. Over time, changes in temperature, powerful winds, and the moon's gravitational pull set it in motion. Warm surface waters began to rise and move slowly toward the poles. Cold water sank and slipped back toward the equator. A slow, endless rotation began, like the turning gears of a colossal planetary engine. This was the birth of thermohaline circulation. Thermo for temperature, haline for salt. It's not just a current. It's the bloodstream of the Earth. It moves heat, nutrients, carbon, even life itself across the planet. Without it, the equator would cook, the poles would freeze, and the biosphere as we know it would collapse. The ocean that breathes for the planet. Let's take a deep breath. Now, exhale. Congratulations. You just participated in the planet's carbon cycle. Roughly a quarter of the carbon dioxide you exhaled will end up back in the ocean. The ocean absorbs carbon dioxide from the air and later releases it back. This slow and constant exchange helps control our climate and has kept Earth's temperature stable for billions of years. In the process, marine life, from microscopic plankton to giant whales, acts like pistons in this machine. Every time plankton grows, dies, and sinks, it pulls carbon down into the deep sea, locking it away for centuries. Scientists call this the biological pump, but really, it's the planet's recycling department. If the ocean didn't do this, we'd be living on Venus right now. Same sun, same size, just a little less fortunate with the thermostat. How the ocean built the continents. Most people never realize this. The land we walk on was once born in the ocean. Deep beneath the waves, molten rock rises through cracks in the seafloor, cools and slowly builds the foundations of our continents. For millions of years, this rock is recycled. It gets pushed down, melted, and born again. The whole ocean floor is in constant motion, slowly forming and then vanishing, just like a massive stone conveyor belt. The movement of Earth's plates is driven by heat from deep within the planet. But it's the ocean that makes this motion possible. Its water seeps into the crust, softening the rock and letting continents slowly glide across the surface. No water, no tectonics. No tectonics, no continents. No continents, no life as we know it. So next time you hear about continental drift, thank the ocean. It's the reason we have mountains, volcanoes, earthquakes, and real estate. The abyssal plains, Earth's hidden vaults. Now let's journey further, past the sunlit waters, through the twilight zone, to where the last light fades and the immense pressure begins. Welcome to the abyssal plains, the largest, flattest regions on Earth. They cover more than half the planet's surface, and yet we know less about them than we do about the moon. Here, dead life rains down from above, a gentle snow of organic debris called marine snow. It falls for weeks, months, years, feeding the deep sea floor. Layer upon layer, it buries carbon, minerals, and the chemical history of the planet. Every centimeter of mud here is a page in Earth's diary. If you dig deep enough, you can literally read the planet's memory. Every mass extinction, every climate swing, every rise and fall of oxygen written in sediment. The abyss is not empty, it's archival. The deep ocean, Earth's secret climate sponge. Imagine a giant sponge lying in the deep ocean. When excess heat builds up in our atmosphere, this abyssal sponge soaks up over 90% of it, acting as a slow-motion climate regulator. It's like the planet's thermal bank, storing energy when times are hot and releasing it slowly over centuries. The same goes for carbon. The deep sea locks away roughly 38,000 billion tons of it. That's 16 times more than the atmosphere and land combined. And that's why climate change is so tricky. By warming and acidifying the oceans, we are destabilizing the planetary engine that has maintained Earth's climate for eons. It's like revving a 4-billion-year-old machine without knowing where the brakes are. Life adapts. The engine evolves. From the first microbes to whales, life and the ocean have evolved together. When the ocean chemistry changes, life changes with it. When the continents move, the currents shift, and ecosystems transform. Over time, coral reefs grow, change, and decline, just like civilizations. Ocean currents create routes for migration. Rising waters bring nutrients that feed plankton, fish, and humans alike. The ocean doesn't just support life, it shapes everything we know. Somehow, life learned to give something in return. Through the quiet rhythm of breathing and light, it began shaping the air and water that sustain it. A timeless exchange, nature's oldest alliance between life and the planet. We humans like to say we run the world, but if the deep ocean ever stopped moving, we'd all be extinct before our Wi-Fi reconnected. Think about that next time your GPS complains you're out of range. The ocean doesn't need satellites. It's been navigating for 4 billion years.
Act 4, The Human Ocean, Now and Beyond. Series. What Lies Beneath? The Secret History of Earth's Deep Oceans. Half of the oxygen in your lungs right now was made by invisible life floating in salt water.
So here's the twist. You're already part ocean. Your blood has the same balance of salts as seawater. Your body is 60% water. Your first home. A warm, dark liquid world. Your mother's womb. Your blood has the same balance of salts as seawater. Your body is 60% water. Your first home? A warm, dark liquid world. Your mother's womb. Humanity didn't just explore the ocean. It came from it. And now we're changing it faster than any force in history. Context. For billions of years, the ocean ran the planet on autopilot. It built climates, cycled carbon, moved continents, and nurtured life. Then something unusual happened. One species, clever, tool-wielding, slightly hairless, started tinkering with the controls. We built ships to cross it, machines to fish it, cities to dump into it, satellites to map it. And somewhere between discovery and dominance, we forgot that the ocean doesn't belong to us. It is us. Today, every drop of water on Earth is touched by human hands, chemically, climatically, or biologically. Even the deepest trenches now contain traces of our civilization. Plastic, mercury, carbon, noise. The ocean once shaped humanity. Now, humanity shapes the ocean. The sea that built civilization. The ocean was our first highway. Before roads, before borders, before Google Maps, people followed tides and stars. Ancient Polynesians navigated thousands of miles using only the motion of waves and the songs of birds. The Egyptians built reed boats. The Phoenicians sailed by Orion's belt. The Greeks turned the Aegean into a marketplace of ideas. Without the ocean, there'd be no trade, no exploration, no globalization, basically, no internet. The sea didn't just connect continents, it connected minds. It carried languages, crops, stories, and diseases. Every empire from Rome to Britain was a maritime empire. The human story is written in salt water. The ocean as resource and reckoning. Then came the age of extraction, fishing, oil, minerals, shipping lanes. Today, 90% of global trade still travels by sea. We pull nearly 100 million tons of fish from the water every year, and that's not counting what's thrown away. The ocean floor is being mined for cobalt and rare earth metals. Deep sea drilling pumps billions of barrels of oil. And the strangest part? Most of this happens out of sight. We treat the ocean like a credit card with no limit, but the balance is coming due. Coral reefs are bleaching, oxygen zones are shrinking, and plastic, it's everywhere, from the Mariana Trench to your dinner plate. Here's a fun fact. There's now more microplastic in the ocean than there are stars in our galaxy. And unlike stars, they don't make wishes come true. The sound of humanity, even noise, travels differently now. Ships, sonar, and drilling rigs have made the deep sea loud. To us, it's background hum. To whales, dolphins, and squid, it's chaos. An invisible storm of sound that masks migration routes and hunting calls. Imagine trying to have a conversation in a room where someone's vacuuming 24/7. That's what it's like for marine life right now. Some whales have started singing louder to be heard. Others have changed their routes entirely. The ocean's oldest language, sound, is being rewritten by human noise. The ocean that fights back is patient until it's not. When we heat the air, it swallows the excess energy. When we fill the sky with carbon, it dissolves it. But every system has limits. Now the ocean is warming, expanding, rising. Tides creep into cities, Miami, Venice, Jakarta. Storms grow stronger, coasts erode faster. And the same waters that once gave us civilization are now threatening to take it back. It's poetic, really. We built our future on the shore, and the tide is coming home. The new frontier, the digital ocean. But it's not all doom. The ocean still inspires awe and innovation. New technologies are letting us explore what we once thought unreachable. Autonomous submersibles map trenches miles deep. AI systems listen to whales in real time. Scientists are finding microbes in deep-sea vents that could hold the key to new medicines, even cancer treatments. And guess what? The ocean is now part of the internet itself. Literally. Over 95% of global data travels through undersea cables. Your message, your video, your search, all surfing along the ocean floor. So next time you watch a cat video, thank the Atlantic. The future ocean, a choice between two worlds. Right now, two futures are forming beneath the waves. In one, we keep using the ocean as a dumping ground, a mine, a machine, until it turns on us completely. Rising seas swallow coasts, coral ecosystems vanish, fisheries collapse. In the other, we remember what the ocean really is, a living system, not an infinite resource, a partner, not a servant. We already have the tools: sustainable fishing, oceanic protected zones, green shipping, carbon capture, reef restoration. We just need one thing we've never been good at: restraint. Reflection. Act 1. So now we know how the fire became blue, how a molten planet learned to flow. Earth's first ocean was born from chaos, sculpted by volcanoes and delivered by comets. It tamed a violent world and gave life a stage. Act 2-4. Billion years ago, the oceans were deadly. 3.5 billion years ago, they became miraculous. They went from acid to chemistry, from chemistry to life. The same water that boiled with iron now shimmered with cells. Act 3. For billions of years, the deep ocean has kept Earth alive. It breathes for the planet. It moves the continents. It regulates the climate. It stores our history and maybe our future. For 4 billion years, the ocean has been the planet's architect. It gave birth to life, built continents, powered evolution, and now it's testing us. Conclusion: it's no longer the ancient engine working in the background. It's part of the story we're writing right now. The question is simple: will humanity become the ocean's next great experiment, or its biggest mistake? The sea doesn't hate us. It doesn't love us either. It simply responds. And like any engine, it follows the laws of balance. What you put in eventually comes back out. So as we stand at the edge of the Anthropocene, staring at the horizon, remember this: the ocean isn't asking us to save it. It's asking us to stop forcing it to save us. If you enjoyed the video, leave a like and subscribe to What Lies Beneath: The Secret History of Earth's Deep Oceans. To stay up to date with the latest news, hit the bell so you don't miss a thing. See you next time. If you enjoyed the video, leave a like and subscribe to What Lies Beneath: The Secret History of Earth's Deep Oceans. To stay up to date with the latest news, hit the bell so you don't miss a thing. See you next time.